Just like any other kind of story, the story of Antarctica's ices could begin pretty much at any time, but it could as well not begin at all. Well, let's assume it still starts one day. After having spun more than 4.5 billion of times around its sun, the planet Earth was about to experience a slight little perturbation in its entire equilibrium. Wait a second, please. Better like this. So, at that time, the South Pole was pretty popular. Therefore, Antarctica was not the only piece of land standing there. Actually, both Australia and South America were really close to the polar region. So close that they were linked to Antarctica's land. Since Antarctica was obviously totally green, no major ice sheet was present on this side of the planet. Spoiler, the other side was just as green. That's why we said that Earth was in one of its greenhouse periods. Antarctica was experiencing at that time a subtropical climate and therefore was populated by trees such as palm trees on the coast and beech trees inland. And many animals such as marsupials were super happy to spend some nice time at the end of the world. However, all good times have an end, and radical changes were about to happen in the polar region. At some time, Australia had to leave the south because of Antarctica's wish to be independent. Tectonic plates respected their will, and the so-called Tasmanian Passage opened on a well-localized subduction zone. As far as I can remember, South America was not as easy to convince as Australia, but finally long negotiations ended and a similar separation occurred, opening the so-called Drake Passage. The consequences of these decisions impacted the entire water stock exchange in the Southern Ocean. Up to that time, ocean currents were used to flow south along the continents and then back north at the first land in their way. But when they realized no one was standing on the path anymore, they decided that it was more enjoyable to spend a bit of time spinning around Antarctica before leaving back. Altogether, currents turning around Antarctica founded the Association of Currents and named themselves Antarctic Circumpolar Current, soon shortened APCC for convenience. Because of its proximity with Antarctica, the APCC accepted to filter incoming heat fluxes, isolating Antarctica from any external disturbance. However, this decision was really contestable, because the current trend of temperature over the planet had been going downwards since a few million spins, and this global reduction of incoming fluxes from the north did amplify the cooling of Antarctica, so it had to give up its vegetation. And that was just the beginning of hard times. We called this epoch that succeeded to the Eocene, the Oleocene. Antarctica's face was about to radically change, and it began with the mountains. Since high grounds are colder than the average surface, they were the first to experience snow. When temperature gets too low, rain droplets turn into snowflakes. Those solid rains are called snowfalls. It's the first process of a long list of transformations that will turn Antarctica into a painting of what is called the Cryosphere. Oh, just in case you haven't heard about Cryosphere before, it's an abstract ensemble that includes all of the water molecules present under a solid state all over the Earth's surface. Hope it's clearer now. A while after the first snowfalls, the soil temperature of Antarctica got cold enough to freeze, and remained frozen for at least 2 years. Insane! Now Antarctica gets permafrost! And let me be clear, it's alright if a few meters of soil at the surface remain ice-free. They will just not be part of the permafrost. Hopefully, they'll do their job of keeping it up. Oh, and just quick recommendations. For the core permafrost, try rocks or sediments, and for the isolation, vegetation or snow should be good. Okay, but we got a problem. All of this permafrost could melt away at any time if summer was a bit hotter than usual, which lacks of seriousness regarding Cryosphere. We need something more resistant. Let's try glaciers. For those, back to our mountains, the coldest parts of the region, since they have decided to stretch out. So what happens if enough snowfalls accumulates on the ground? Well, if summer was not warm, some of that snow could still be there a spin later. Let's call it Thian. Good news! The more snowflakes accumulate over each other, the more pressure the pile gets. And in case they chose to let a bit of space between each other, snowflakes now need to hug and feel close. But believe my word, they will always try to keep a bit of personal space. So there will be pores. And by the way, what's in the pores? Air. Nothing to see, but lots to be discovered. Oh no, the air is now trapped here. Anyway, it sounds legit to say that we got ice now. Now the top of our mountains got mountain glaciers. And guess what? Since mountains are steep, the ice flows. Now you may ask, how is it possible? Just listen. Glaciers are heavy. I mean really heavy. And what happens if you drop anything heavy on a slide? It slides on the slide. Then, if you're a glacier, you flow. At least until you're too far down, because it's too hot here. Then you melt. The altitude where you stopped is called the equilibrium line altitude. Oh, there are some good news incoming. Since the temperature is still decreasing, glaciers can flow further. And this trend is not likely to stop there thanks to the ice albedo positive feedback. Oh, maybe you don't know what the ice albedo positive feedback is. Then let's make it simple. What happens when sun rays hit the ground? The ground absorbs the sun energy and then warms up. But what if this ground is now covered by ice or snow? Well, snow and ice are bright, right? Then they reflect the sun rays back to the infinity of the space. But the ground can't warm much if the rays are leaving so quickly. So the more surface gets covered by snow or ice, the colder it gets. And you guessed it right. The colder it gets, the more ice there is. QED. So good news for the glaciers. They can extend even further. But wait a second. When ice leaves, there's no more ice on the top of the mountain. Oh, sorry, I totally forgot to mention that glaciers flow lasts decades. So hopefully new ice have formed meanwhile on top of the mountain. Time goes by and glaciers have now extended enough to be called ice caps. But wait, ice has now flown down to flatlands. So the concept of ice flow becomes even more abstract. No worry, as long as new ice continues to accumulate somewhere, then this ice will pressure its neighbors to get more living space. So even on flatlands, ice continues to flow. And when those ice caps have extended to more than 50,000 kilometers square, they evolve into ice sheets. And when these ice sheets finally reach the coast, ice meets ocean. Nice, but we got a problem. A problem? Water is too warm. And since it's liquid and therefore supposed to be warmer than 0 degrees Celsius, it will be too hot for our ice sheet. Okay, let's try anyway. So our ice sheets continue extending over the ocean, try to go farther, try to go beyond the limits, try to wall the entire wall. But the ocean was too warm. Ice melted before. Unlucky. So, I guess our ice sheet will end here, on the ocean. Let's call this last piece of ice an ice shelf. Okay, but I guess we forgot someone. Who? Where? On the ocean. I thought it was not possible for ice sheet to extend over the ocean. Yes, but in case the ocean surface gets too cold, it convects a lot and then its surface freezes in little blocks. And why didn't we talk about it before? Actually, it took a while to cool down all of the ocean surface, but at least now we're down. So we have ice blocks forming at the ocean's surface. And now we are supposed to look at them miserably sinking down to the bottom of the ocean, right? Not really, since water was created in such a way that ice is lighter than liquid water. That sounds ambiguous, but let's assume it's true. Then the ice weight gets offset by an upward buoyant force, thanks to Archimedes. Thanks to whom? Long story. Anyway, at some point, a big part of the southern ocean got covered by this so-called sea ice. However, part of it is likely to melt during next summer. Hopefully, it should refreeze later if conditions are still cool enough. It still looks much less reliable than ice sheets. The latter is the only one being here 24/7 to represent Cryosphere. Oh, wait a minute! Have you heard about it? Competitor North Pole is currently forming its own ice sheet. It looks like a Cold War. Well, let's wait a while until he is done with it. Should be good now. And that's how Earth left its current greenhouse period. We are now into an icehouse period. Sadly, following times were pretty boring. I propose we skip a few million spins, up to here. We're now at a time when Antarctica's land surface was so cold that not a single animal accepted to live there. Actually, some of them were still okay to live in the nearby waters, but it was at the cost of several adaptations. I can remember of quails, blue whales, penguins. Oh yeah, and now that I think about it, I believe penguins who still wanted to try live in the lands. But since the other one refused, they had to live close on the coast in order to feed themselves. And so Antarctica became the most hostile place on Earth, a place whose independence was not to be challenged by anyone anymore. The coldest and windiest place on the planet, the kind of place that sends you a shiver down the spine just by thinking about it. The place everyone decided to leave, and where no one would dare to live anymore for a really long time. Really, no one? Okay, maybe just one species. Mankind. I can't find it on the timescale. Is that normal? It didn't last long enough to appear there. Alright. Then what happened to it? And why would it care about Antarctica? Let's start from the beginning. First, men proliferated and spread all over the rest of the planet. Then they decided to divide Earth with fictional boundaries, resulting in the creation of 195 so-called countries. But that was not enough. They wanted more. So they tried to go south, to the last place they didn't have the opportunity to touch for now. Antarctica. Did they swim? Or fly? Let's say neither one. But long story. So, it took them multiple tries to reach Antarctica, but finally they walked on the land surface and even arrived to the South Pole. However, Antarctica's face at that time was probably not its most hospitable version. An infinite white desert, 98% of it covered by 2 km thick ice, with a temperature of minus 10 degrees Celsius on the coast and minus 50 degrees Celsius in the inland, down to minus 90 degrees Celsius in the winter. I'm not able to understand what was driving them there. They were curious. They wanted to understand the world they were living in, discover its landscapes, and that's pretty much it. Anyway, 12 human nations decided to split this continent into 7 fictive portions, like a pie, unequal, however. It took place during their so-called Cold War, in 1959, if I use their calendar. They signed what they called the Antarctica Treaty. Then they decided to analyze everything that could be analyzed, including the ice itself. Did they dig? Even better, they drilled. They used mechanical energy, but let's call this black magic. So they extracted what they called ice cores, composed of ice older than 100,000 spins. 1 meter of those ice cores was equivalent to approximately 80 spins, the lifetime of a 1 meter and 70 centimeter tall man. And guess what they found in the ice? Air that was still trapped here since the ice formation. By analyzing this air, they highlighted a correlation between carbon dioxide concentration and the Earth's temperature. It was as easy as the following statement: the more of this gas was present in the atmosphere, the higher the temperature. But that's not the only information that they got from those analyses. Actually, much more recent ice cores formed during the past century were revealing carbon dioxide levels that were exceeding by far the one from their previous observations. Those trends were revealing the reality mankind created by itself. Its curiosity had been going too far, leading it to be responsible for this unfortunate event. At least, unfortunate for itself. Humans were warming up the planet back to where we started. And it began with a warming of the atmosphere, soon followed by the oceans. No good news for the ice. Hopefully, Antarctica's temperature was still pretty low, therefore melting was not about to happen on the land. But then, what happened to the ice? Changes in temperature created a change in the winds. Therefore, the ice sea was on some places brought closer to the land and on some other farther from the continent. Combined with a new repartition of warm air all over the ocean, parts of Antarctic sea ice extended when some other retreated. Hopefully, the APCC was standing tall and did not move from an inch, but he was not able to protect Antarctica from every incoming heat flux. That's how changes in wind patterns and ocean currents ended up warming the coast. But once more, Antarctica was not ready to give up so easily. Thanks to a global snowfall increase, the East Antarctica's ice sheet was able to gain some ice. Unfortunately, the West Antarctic's ice sheet was not so lucky. Most of its ice shelves were threatened by heat currents coming in. Therefore, first meltings occurred, attracting even more heat fluxes due to the release of fresh water. And the cycle was not about to end here. The increase of incoming heat fluxes at the base of the ice shelf could lead to an entire instability of the ice sheet. And once instability gets too far, a piece of ice could just break away. Antarctica was the last place on Earth resisting to human grasp, standing tall against its pressure. But when pressure gets sustained for too long, processes can become uncontrollable, and such consequences can be felt all along a human lifetime. It was now up to humans to decide of Antarctica's ice's fate. But one thing was sure: when the ice melts, it's the entire past of the Earth that melts with it.